please raise your hand so that I can get who have doubt. Okay, then we will do something on week 8 as a revision, not revision, that is a summary. No one have doubt? No, no one have doubt. Okay.
Sir, in the lecture
Hmm.
L 8.1, there are useful rules for regarding continuity of the function at a point. Can you can you give examples regarding how to solve the continuity of such algebra? Like there is a limit f of x to f and g and f plus g, f minus g, such that
Yeah,
I'm
so
finding it difficult. I'm finding that thing as difficult.
okay, so where is that? In which lecture?
Lecture 8.1, limits and continuity.
Okay, so you're not understanding what is the
Like how to apply all this algebra rule. Can you give some examples
okay. So
and
for
do in the quiz too or in the end term exam? Such types of question will be asked or not?
yeah, if it is in the syllabus, maybe it could ask not exactly same, or it the
Yeah.
concept, surely the concept will be there, no? So maybe concepts, particular question may use the concept, that concept. So
Acha.
let me create an example here, which is 1 minus x when the case is x is less than 0. Okay, and this is 2 when x is equal to 0, and x 1 plus x when x is greater than 0. Suppose this is a function you have. So please let me know, are you getting what is this function?
So piecewise function, like it's a number line. X is less than 0 means all the negative. X is equal to 0 means the point, and x greater than 0 means all the
Yes,
positive.
yes. So the graph would be like of this function, how the graph it would be. See this, when the x is less than 0, the case is here, this side, no?
Yeah.
So this side and this side, the function behave like this,
Yeah.
1 minus x.
Mm.
So if you draw the graph 1 minus x, how it would be? It represent a line, as this is a linear function, right?
Yes. Yes, sir.
So the graph will be, suppose here is 1, here is 2, and here is 3. So graph will be like this. This line represent, actually this negative sign is here, no?
Hmm.
So line will be that side. The slope will be negative. And when is x is positive, the function we have like again a linear function, but see that how it is, this line. And this line means, again you can see that this is x-intercept. This is, sorry, y-intercept. This is y-intercept. At 1 it will intersect the y-axis, correct?
Hmm.
So that means again here, from here it will go. But at
Yes, sir.
0, exactly at 0, the value is what?
2.
Yes, not 1, it is 2. So here at 2 exactly the value, but here is, we can think as a circle, like circle means, the function
Yes.
value is
Open.
not assuming that
Yeah.
point. So this is, we have the function. Now, can you tell me, is this function is like we draw the function, so this function is continuous?
I feel that it is continuous because at x is equal to 2.
No, sir,
No,
it's
no.
not
No.
continuous.
Yeah. Uh,
No, it's not continuous, sir. It is jumping at 0.
yeah.
So it's look like here the jumping, but suppose I just erase and forget about this graph, okay? Forget about this graph. So from just looking this function, can we conclude that is this function is continuous or not? This is the problem. That's the, I think he had asked. He is having he is asking that how to deal with such problem, right? This is
Yes,
doubt,
sir.
no?
Yes, sir.
Without looking, if you are unable to draw the graph, how we will solve this problem? So for that, like each time we are unable to draw, like suppose I have here given a very complex expression, suppose even a different polynomial, the whole polynomial, let's say this is x square, not x square, 5x, a bigger polynomial. Okay, this is the polynomial of polynomial of higher degree. So in this case, how we will deal? So let me erase it here. Now this side is not line, this side is a polynomial. We don't know how it is, but the problem is this, this is 5 here. So is this function is continuous or not? So how we can do this? How we will solve? So
If it is
so,
differentiable, then it is continuous. If I'm
so differentiability is more sufficient condition to check the continuity. Before to reaching that, we have one, no, that left limit. What is left limit? I will tell you. Right limit, okay, or right hand limit, and function value. And so both implies a limit of function. And if this is equal to function value at that point, limit of the function at that point should equal to function value at that point. Correct?
yes,
If these two things, like everything is happening in this case, you will say your function is continuous. If the limit value of at that point is equal to the function value, so let's check here, is limit value is exactly equal to the function value at 0, and we want to check at 0. Okay. At 0, is the function is continuous or not? So let's find the limit. So we want to find the limit of the function as the x goes to 0 of fx. Correct?
yes, sir.
So, but this function is divided in stepwise at exactly 0. That's why we need to consider we have to consider left limit and right limit. As the left, as here, if you are 0 is here, 0 is here. So here is to approach 0. Here is two ways. Correct? Two ways we can go, left side and right side. And our function itself also we having left side of 0 and right side of 0 in a stepwise. So that's why we have to consider the left and right limit. So to get this limit, before to get this limit, we have to get the limit, left limit. Okay. So limit, left limit, how we will denote it?
0
X
minus.
has 0 minus. Then this is f of x. And what is this? At 0, you are negative, from the negative side you are approaching to 0. So what is the value? What is going to be the limit? We are coming to this side, coming to 0 from this side. So which function will work here?
The first one, sir, x for 5 plus 9.
First one will work. So first one will work. So to find the limit, what we can do, just need to substitute x is equal to 0. No?
Yes,
so
sir.
if you substitute here, the limit will become now finally 1, as
1.
x to the power 5 plus 4x plus 1 is there. Correct?
Yes, sir.
And let's find the right limit. So right limit, if we will try to find, so again the right side of the 0, the function we having like this one, which is again a linear function, which is, you can say different word, it is a polynomial also. Again just need to substitute here. So let's substitute here again. So again you will get, once you substitute here, you will get 1. So what it says left limit equal to right limit, right? So that means your limit at 0 is exist and exactly equal to n, as the left limit and right limit are both are equal. In that case only the limit is exist. Correct? So see that we are not, we have seen here the graphically, but let's do, we are doing here with the algebraically, more pure mathematically, not even we are thinking the geometry also. So whatever we have definition, using that we are reaching. So we got that limit at 0 is 1. Now let's find the function value. To check the continuity, limit value should be exactly equal to the function value. So what is the function value at 0? This is 2, right? As we have. So that means our function value is not equal to limit value. Correct? This is the function value and this is not equal to 1 is not equal to 2. So in this case, as we have seen in the graph, it is actually, we have seen in the algebraically way, more as we have definition in the algebra form, that the function is not continuous at 0. So is this fine?
Yes, sir.
So this is one way, not one way. This is the always a way to, without going the graph, we need to check using the algebraic definition of limit, continuity, differentiability even. So let's do a summary again. If anyone else have doubt, please let me know. Or we have in week 8, limit is there, differentiability, computing, L'Hopital rule is there, and derivative and tangents. Okay, only till tangents is there. Okay, linear approximation, the tangent and linear approximation. So we'll see it here slowly. So let's discuss in. So limit is just now whatever we're discussing, no? Exactly. So let's find some limit. Suppose we have a function limit. We want to find the limit. Suppose we have a function fx is equal to 4x to the power minus 1, okay, plus okay, 4x to the power minus 1 plus 3x x to the power minus 3 upon this is 2x to the power minus 1 minus 3x to the power minus 3. So, and we want to find limit. This is for infinite case. What is going to be the limit of the function when fx approaches to infinity? So again, this is fx approaches to infinite means just remember that you are given input a very large number. Think at for the whenever you are solving, no, so think this tells you that you are giving input as a very large number, very large number. So infinite means very large number, and you are giving the inputs are very around that large number. What we don't that is not fixed, but we are giving input very large number. So what is going to be the output? Is it we are getting some output that some fixed number around that we are getting some output, like here is some fixed number and we are getting output around that? Is that possible when we are doing this as very large number giving input? So that number we want, which number is there around that, always we will get any large number we will substitute here, always we'll get the output around that only, that number only. So we want that, that's the limit of the function. Okay, is it clear? No?
Yes, sir. Yes, sir.
Okay, so what is going to be here the limit?
The
Please
0.
0. Okay, anyone else? So yeah, who have solved? Can you tell me that how we will solve? Yes.
It should be 2.
Why? So yeah, please let me know how we'll solve this so that it will be 2 or
We have to divide by x minus 3.
okay.
X raised to minus 3.
This will divide with that, okay? Means yes, if we divide with that, so what will get here?
4 square.
This
X
will get
square plus 1.
okay.
And 2 x square plus here minus 3.
Minus 3. Okay, we'll get this one. Okay.
Then again we can divide x square.
So now this could be cancel out. We can divide with 2 x square. So this is 4 plus 1 by x square upon x square again. This is 2 minus 3 by x square.
Yes.
This will cancel out, and this is finally we have this one.
This
is
will 4 by 2.
This is as we now we will take limit. So as limit will take in numerator and denominator. So this will whole term will go to 0. This whole term will go to 0 as denominator of this term is very large number. So 1y of it become very small number. So that's way you can say as x goes to infinity, that the terms will go to 0. So that means finally you have 4 by 2. That means 2.
Yeah.
So how we are getting then 0? We are missing something. So I think then 0 will not be a limit of it.
Yes, 2 is the limit of this function.
Anyone else got different limit? This way we can also do with the safer case. Exactly whatever we are doing, the same thing we are here is also. This is cube. Now we can take common here. So here it will become 4. Common in the sense LCM, mean to say. This is, if you take LCM in numerator, this is x cube, this is 4x square. It is happening the same thing, same is there, plus 1, yes. And this is x cube again, this is 2x square minus 3. Now we got the same expression here as this one. So by this way also, like if you are problem with this negative sign of the power, so change with the 1 by of it and then do the LCM, the same thing we can do all. So as the limit will be 2. So this is the limit case. Now continuity we just now discussed. The continuity is in more detailed form we discussed here, which is function value and limit value should equal to 0. So let's do one more example, that limit, so that continuity. Let me take an example that let's assume fx is equal to
Sir, in that previous example you have given it, sir, if it is in 0 by 0 form, yeah, we have to simplify it. That is 4x square plus 1 divided by 2x square minus 3. So after that, we can directly substitute the infinity, right? Why we again going for that 1 by x form?
Oh, this one?
Yes, sir.
I thought maybe who don't know what is happening, how to take common, that's why I just made it. Otherwise, I just verified and so and check that okay we are getting or not. And also for you, for making a simplicity, that as we are taking x to the power minus 3 common, so how we are getting this expression, by this way also you can get.
Yes, sir. Just asking you why
Mhm.
we cannot directly substitute the infinity and find the answer.
Not if you substitute here infinity, so what you will get here?
0 at the
I know,
top.
not infinite substitution is, we cannot substitute infinite, we just argue that as, okay, as we are, as x goes to 0, these terms will go to some number. So they, okay, so as you are saying, if you as x goes to 0, the term will go to 0. So okay, this will go 0, this will go 0. So this becoming a 0 by 0 form, no?
Yes, sir. Yes, sir. Indeterminate form. That's why we are going for the this 4x square plus 1 divided by
Yes.
2x.
Yes.
But there we can substitute, right? 4x square plus 1.
So again, not substituting. Okay, you are saying to be substitution word. So again, let's substitute here infinity. The again, what you will get infinite by infinite form, no?
That is also indeterminate.
Yes, as your substitute, it will come infinite, no? This one also become infinite.
Okay, sir. Okay. Got it.
Yes. So by this way again, then we have to very carefully keep our leg on while proceeding this. Okay.
Sir, can
So
you please explain the left limit and right limit of this question?
of this question.
Yes, sir.
So there is no left limit will happen, no? As x goes to infinity means only one side we are approaching here is 0, and we are approaching to infinite means this is only. There is no left limit or right limit for this case. Because as we are looking, no, this is infinity is going, so this is infinity case. This there is only one side is there. Here is if it is 0, right? So there is, in this case, there is no left limit, right limit. If it is some fixed number, let's say this is alpha, here you want to find the limit. So this side is left limit, this side if you approach right limit. For a fixed number, we can do for the left limit, right limit. For infinite case, there is no left limit and right limit. Okay.
Okay, sir.
So let me write an example. Let me write a function which is x minus, okay, this one, when x is, okay, this is, let me write here, when x is less than 0 and x minus when x is greater or equal to 0. Suppose you have this function, okay, and in the broader case also we can think here we can divide with x also. Then yes, this is fine now. So we have this function, okay, and we want to discuss its continuity or where the function is not continuous. So please let me know where the function is not continuous. How we'll solve this problem? It is look like very complex. Here is what is all of you are getting. What is this? This is floor function, means your greatest integer value, greatest integer function, right? It means that if you substitute here, if you want to find the, if you assume x is equal to 5.1, then what will be the output?
5.
5. This is the mean of greatest integer. So this function tells you greatest integer less than or equal to. So we want to find the exactly a bigger integer which is less than 5, less than exactly equal to x. It will not go beyond of it. So this is the greatest integer function. So we have a very complex here a function that looks like in a stepwise, but in steps also it's look like a very complex. So how we will deal with this? We want to find the where the function is not continuous. At 0, it will be continuous or not?
No, sir, not.
Why? What is going to be left limit for this? At 0? Left limit will exist or not even? Or if it is exist, so what is going to be the left limit? Anyone?
6, sir.
Exist.
Yes, yes, 6.
So how you are saying this is exist? Can you give me something, or you did? So please, everyone, try to solve this. Let's see that how it would be. This is a good example. Like it will clear your. You will try to see that how whatever the doubts in your mind will come related to the continuity. We'll see it here. This greatest integer function is the best way to learn. To not even learn, best way to see that how it is creates problem regarding the limit itself or in the continuity. So, okay, let me tell you that left limit is here. What is the left limit? Is that it will exist or not? Suppose, so we want to find the limit of the function at 0 first. Let's assume, like, because we are looking at there is a step in at 0, okay? But when x is greater than 0, our function is also in the stepwise. But here is the function is given itself stepwise in the 0. So let's first find the limit at 0. So to find the limit at 0, this limit of fx should be exist or equal to when the limit of left limit equal to right limit. And yes, when it is this case, then the limit at 0 will exist. So here is equal to 0, or we can give also. This is f of x. So let's find the left limit now. So left limit, this is what our function left side. What is going to be left side?
Floor of x minus y upon x.
That
Yes.
first expression.
Yeah, first expression. Left side as left side means our at 0 we are here. At 0 we are here. So left side is this side. At this side means lesser than 0's values. What is our function? This one. So let's do it here. Okay. Now we want to find of this function when x is approaches to 0 by this way, this side. That's the meaning here, left limit. That means we are trying to give input to this function when we are around to 0, this side. What is going to be the output? What is going to be the output? We want to try to get that. And we are trying to reach, and it is a very close to 0. Talking about x tending to 0 negative here, or to the negative, that means very, very close to 0. What is going to be the output? Is this, so as here we are meaning, this tells you very close to 0. So can we get a number that is called limit? Can we get a number of as a output that the output is also very close to that? Whatever the output you will get, no, here is very close to 0 inputs we are giving. So what is going to be the exact output? Around that we will get that all outputs. Can we get a fixed number here? What is that output? That's the meaning of left limit here. Okay. So let's do it here. Here we have as x approaching to 0 from negative side. What is the greatest integer value? What is
minus 1.
Yes, -1 it will be. The reason is why the reason is anyone else can tell me why the as x approaching or as x approaching or very close to 0, we'll substitute here, or let's assume x is equal to 0.00001 is minus really minus 0.009 is there. It is actually close to 0 left from the left side. So what is going to be the greatest integer in that case?
-1.
So why it is -1? The same definition, greatest integer less than or equal to. So this integer is -1 is the greatest integer which is less than this number. -1 is less than this number, and it is an integer value. -1 is less than -0.001. Correct? Because -1 is here. This is lesser number, less than this number. Suppose here is our minus 0.00. So -1 is lesser than number, and it is also the greatest integer, which is less than x, which is our this number. So that's why the value is -1. So here is, as x is approaching to -0, here is actually it is a fixed number. It is a fixed number, and below of it is what is happening here? So it is a very fixed number. Below of it, what is happening? So you can, if as x goes to 0, what we can do? This is -1, -5. You can simply say that limit as x goes to 0, negative -1, -5 upon x. We can differently write also like this. Correct? Because as x approaching to 0, negative, this value is x, exactly the numeric value will come, which is -1. Correct? This is right.
Yes,
No?
sir.
So in this case, in numerator, which is a fixed number, but in denominator, it is a variable, which is our function. In that case, it is happening -6 by x. Is this function is defined, or we will get output, or what is going to be in that case? As x approaches to 0, where it will go?
Infinity.
Infinity.
Infinity will go. Correct. But it will go positive infinity or negative infinity?
Negative.
No, negative. Here is negative, and here is also negative. Where it will go now?
Positive infinity.
Yeah, it will go to positive infinity. So limit is actually, it diverges. That means limit is not exist at 0, left from left side. Left limit is not exist. See that how a beautiful thing is happening here. We don't know even that this expression, but we break our expression one by one, and reaches that left limit is not exist. Okay. So we got that at 0, left limit is not exist. Let's do for the right limit at 0. So limit as x approaching to 0 positive. What is going to be the limit? So in the positive case, how our function is?
X minus floor of x.
Floor of x. So when x is approaching to 0, what is going to be in this case? Limit is
X minus 1.
x minus 1. Now, no. Why? X minus 1 will not come, no? Because positive side we are approaching. So greatest integer, once you have greater than 0, like the number which is this here we have. So assume x is 0.001, which is greater than 0, right? What is going to be integer, greatest integer in this case?
0, sir.
That means our function as approaching to 0, our function is, again, we can try to change this. So this is 0 positive, x minus 0. That means finally you have approaching to 0 positive, x will get, right? Our function
Yes.
is changed. We can actually write in a small interval, and it is correct. There is no, so we can write like this also. This is a correct way also to write. So this is going to be 0. So right limit exist, which is exactly equal to 0, but left limit is not exist. Okay. So at 0, we don't have limit. If in the whole scenario, left limit is not exist, right limit is exist. So limit as x goes to only 0, not even the left or right. It is just asking limit as x goes to 0. What is that? So in this case, we will say not exist, because left limit is not exist. Correct? If it is exist and equal to 0, then we will say the left limit is then limit is exist at 0. Here is any one of is not existing, then in the same case you will say limit at 0 is not exist. Okay. So at 0 it is not exist, so how it could be continuous, right? Because continuity is asking that the function value should equal to 0. What is the function value at 0 for this function? What is the function value?
0, sir.
0, sir.
0, right? Here is as greater or equal to 0 is there. That means our function at 0 we have like this, which is 0 minus greatest integer 0, which is 0. So can we do something more here? Is function is our continuous. Can we give it as a name? Can we give name as a right continuity?
No, sir.
No, right continuity we can give the name, because right side is right limit is equal to the function value. So right continuity is there, left continuity is not happening, right? Right limit is exactly equal to the function value. So I think sir is not taught in the lecture right continuity. So I think otherwise it is happening a kind of thing. So function value is exactly equal to the right limit. So in the whole scenario, the function is not continuous even, but yes, right continuity is there something, because right limit is x. So forget about this one, but yeah, simply say the function is not, limit is not exist is 0, and the function value at 0 is 0. Okay, at 0 is 0. So in this case, our function is not continuous at 0. At 0 we got that function is not continuous. Is there any other point where the function is not continuous? Now we need to think, right? Some greater values, for some greater values, the function is continuous or not. For the greater values, for greater than 0 values, our function is, we have like this. So let's think it here. Fx is, for the greater case, x is greater than 0. Our function is x minus this function. So can we check limit at 1? Because the problem for the greatest integer function is at the integer. This is a, the greatest integer function is in a stepwise it is, no? So you can see that here is jump always. So there is a possibility that at the integers it could be not continuous. So can we check at least 1? Then we can generalize it easily. So let's find the limit at 1. So again the 1 is, as here the stepwise it is, so we can think it as a left limit and again right limit. So at left limit, once you try to generate here at at 1, what is going to be the limit? Can you tell me? Anyone?
0, sir.
0. No, 0 will not, right? So here is once we try to generate here as x approaching to 1. So what is going to be here? This will become, this approaches to, as x approaching to the left side to 1, this is goes to 1. But this one
0.
0.
1.
1 minus 0, so this is 1. And let's write for the right limit. What is going to be right limit here? This is approaching to, again, 1, right? But here is this one, this will approach to
2.
no
1. 1.
oh
1. Yes. 0.
So 1 minus this is approaching to 1, and this is approaching to the right case is 1. 1 minus 1 is 0. So again we have a discontinuity. You see that left limit is not equal to right limit at 1. So again the limit is not exist at 0. Sorry, at 1. So again, we can say the function is not continuous. So similarly, at 1, at 2, 3, 4, 5, all the integer point right side, all positive integers, at the all positive integer function is not continuous. And for the case of like in between, like here is 1 by 2. For the case of what is going to be limit as x goes to 1 by 2 of fx, what is the limit value?
It will be 1.
So it will be 1. Let's write again. Our expression is this one. At 1 by 2, it will become as x goes, x will approach to 1 by 2. In both cases, it will be have the same. That's why there is, if we can do with the left and right, but still you can see it here. It is a very safe zone. If you go with the left or right, still it is the same value will give you. So it at x goes to 1 by 2, it approaches to 1 by 2, and this approaches to this will what?
1.
No. Why it is 1? Again, you just need to substitute, no? This is the greatest integer value of 1 by 2, which is 0, right? So 1 by 2 minus 0, which is 1 by 2. And what is the function value at 1 by 2?
1 by 2.
Function value at 1 by 2 will be exactly 1 by 2. Just need to substitute here. Just if you substitute here, this is 1 by 2. And this is again 1 by 2 greatest integer. So which is again 0, which is 1 by 2. So at in between the, so see that the function value equal to the limit value. This function value is equal to the limit value. So in between this point, in between except the integers, the function is actually equal to continuous here. This is not the graph of this one. Okay, this is not the graph of this one. But here in between the limit, here is the in between the integer, except the integer, the function is continuous, but at integers it is not continuous. Okay. Now similarly, here is we got that for the positive case, no? Similarly, we can think for negative case also. At negative case, also there will be a jump as the reason of integers there. Correct? So again, there will be a jump. And also, yeah, at 0 will not there, so it will always, we are able to get the limit, left limit, right limit at integer, but again there will be a problem because of this greatest integer function. So same, very similar to this one. Very similar to this one. Again, we can also very similarly conclude that at integers in negative side also function is not continuous. Okay. Is it clear?
Yes, sir.
Okay. Please stop me if anyone is not getting. Please let me know. So how the TA session is going? Anyone have attended yesterday's TA session?
Yes, sir.
How was that?
It's good.
So what is the attendance in that session when you joined?
Sir, 29, 24. Like,
Okay, 29, 24. So how the instructor like TS is teaching, is that good, understandable?
yes, sir.
Okay. Okay. So there is no mock is also going on. Anyone have attended that mock? Mock is also announcement already sent you. There is a mock is happening for week 5 and 6, for which it will come. Try to attend this mock. I think yes, tomorrow is going to be the last date. 29 is there. So this mock is for the logarithmic and exponential function. Okay, try to attend this, see that how it is happening, how you are performing. Okay, and the solution will be posted after 29. Okay, please everyone try to this mock. So nowadays, like all of you are very in relaxed mood, or now the quiz is coming, no, quiz 2. So all of you are preparing for that, or only just, can you please tell me that? That would be good to know that what is happening with
There is no relaxed mode in this course actually. From 1 to 4 we had a lot of time. We feel like now actually that time we were complaining there is no time, but when seeing this 5 to 8 we see that is okay. 1 to 4 we had enough time. Now it is going very quick actually. We
Yeah,
had almost a week
then
to
one,
prepare for the week 1 to 4 quiz 1, but here we don't have actually the deadline for both the weeks are the same date, 7 and 8. It's not relaxed. We are not relaxed. We are not allowing us to relax actually.
So my suggestion is this week 5, 6, 7, and 8 will be come for this week quiz 2, and please more focus on this, solving the logarithmic and exponential equation, no. So try to solve those and at least get that, okay, how to possibly get the number of solutions. So maybe similar question you will get, that is from the log usually we have. Okay. And in the 7 and 8, try to get the limit of sequences and limit of functions. Okay. And continuity, because till 8 we have, so till 8 is only on derivatives also there. Yes. Okay. Okay. So try to reach. The question will not occur, but at least you should to know here. So try to attend this mock. We'll do the revision session, and someone is some.
Week 1 to 4 we did 2 sessions of PYQs also after revision.
Sorry, some background noise is coming. Someone else is speaking. I think. Please, just a minute. Just a minute. I think from my side it is coming. Okay, it is automatically played here from my side. It is okay. Okay. So sorry. Could you repeat, please? What are you saying?
So will there be any PYQ sessions? Will there be any time?
Yes. Again, there will be a PYQ session now at Friday. No, from Monday onward, we have a TA session. How many TA session we have? We have, on Monday we have, and Thursday we have, Friday and Saturday we have 4 sessions. So at least in this 4 session in the next week, you will see that which is here. Okay. So in next week you will see the PYQ session. Okay. Older question QP discussion from next week. Okay, there will be with the TS again. Okay, this is one thing. So anyone have attended this mock week 5 and 6 for mock 5 and 6? Anyone tried here? Anyone who is present here? Anyone tried for 5 and 6?
Yes, sir, I've done almost half of it and I was solving it right now.
Okay. Okay. And
So there's one doubt. So sometimes we use fg of x to denote product and sometimes for composition. How do we differentiate between the two cases?
so, okay, sometime like so it will be written in the case like fx and gx. If it is written in this case, this is a product. Okay, this is a product, And if it is written in this fashion, then it is a composite. Okay. So be clear, and also in the question you will get the in this format. This is a product, and this is in the, if it is in this format, this is a composition.
Yes, sir. This is clear in this notation that I'm writing in this chat right now.
Okay, let me show you what is that. Yeah, please write in chat. Let me see. So this is also a composition. No, this is this whatever you are writing this. This is actually a composition. One minute. This is here is not circle. Just a minute. FG and X is there, and F circle G. If it is this case, then so this case is actually sorry. So this is a product. Okay, this is product. Okay, this is this product is given, and if it is this in this fashion it is written, here is O is there, so this is composition. Okay,
Thank you, sir. It's clear now.
this is composition and this is product. Somebody
Yes.
has raised. Yes, Manish, do you have something?
I have a small dot in log.
In log,
Yes, sir.
what is your doubt?
Sir, if log x to the base 4 is less than 3, then what value of log x to the base 10?
If the log, could you repeat please?
Sir, if log x to the base 4
Log x to the base 4, okay, yes,
less than 3,
less than 3.
yes, sir, then what value of x to the base 4 at 10?
So what is going to be the value of 4?
x to the base 4, yes, sir.
X to the base 4, x to the
Log x to the base 4.
log x to the base 4. So what is going to be the value here?
Yes, sir.
What if it is less than 3? So what are the values we will get here? So this is the same, no? This is just draw the graph, easily get this is 4, no? So 4 is actually greater than 1. So graph of log function is exactly same as usual. Here is 1. At 1 it is 0. And you want to at 1, this is lesser values. At 2, let's say this is 2 here, this is 3 here. So these are the values which is lesser than, these are the values you will get which is lesser than 3. Okay, just use the graph, would be easily to understand. Otherwise exactly giving the values is difficult, but while looking the graph you can tell that okay, these values are actually lesser than 3. Sorry, output, no, sorry, this I made a mistake here. So output, these are the input, no? So output is here. So output here is log at 4. At 4, it will be what value? If you assume x is equal to 4, what would be going to be the output? 1, right?
1, yes, sir.
So at least till 4 it is 1. So here is, assume it here till here is 1. Okay, this is 1. And 4, 5 to whatever the value which is, so these values will come, no? 4, but again the value is till here I think will come. I suppose at 8, x is equal to 16. For x is equal to 16, what value will come?
2.
2. And for x is equal to 64, what value will come? 3. Till 64, the value is still 3 only. Here is input, if you gave 64, here is 3. So these values are actually lesser than 3. Okay. Now is it clear?
Yes, sir. Sir, why we cannot take log x to the base 4 negative value? Like -1, -2.
So the reason is that if you see the definition of exponential, no, exponential case, what is the definition of exponential function?
Yes, sir. Range is 0 to infinity.
No, so before that, to define that, what is the 0 to infinity? No, the definition of exponential is a to the power x, where a is greater than 0.
Yes, sir.
It cannot be.
So that's why the log is actually the inverse of exponential, correct?
Yes, sir.
So how it could be negative? It could never be negative, because we are getting log is nothing but the inverse of exponential.
Okay, sir. Got it.
Okay.
Thank you, sir.
So let's move on to, we did something on continuity. Let's move on to derivative. So
Excuse me, sir.
Yes.
So it's
Yes.
a continuation of the same thing. So in activity number. So in activity number 7.2, so the question is taking like fg of x, like I was asking, but it's using product, like composition for answer.
Okay, 7.2.
So third question.
This one.
Yes, sir.
Okay. Here is the answer is as a composition you got. Sorry, product.
So I typed the answer using product, but it's incorrect. It's using the answer using composition instead.
Okay, okay. Here in between the circle will be. Without that, it is not correct. Here the circle will be. This is telling you of the product. Yes. So if it is a product is given, then it is a wrongness there. It is like it is a composition is given, then it is a wrongness. That is a product sign. That is that. This is.
Okay, thank you, sir.
Yeah, this is a product.
Yes, sir. Thank you, sir.
Okay. Okay.
Sir, regarding the logarithmic functions, whatever the formulas like log of m into n, those things have been explained in the lectures, but in the activity and in the graded assignment also, a lot of formulas have been used which is not explained in the lectures. Can you give us one complete list of that?
Log in the log.
Yes. Yes.
Okay, so easily see, you are asking, so I will just search and can give you that log function. That's the one way. Log formulas you can search also.
Sir, in that last graded assignment of last question, it is like a log to the base b c, that is converted to the other one. That was not clear actually earlier.
What is that? Could you repeat, please? Log.
Sir, m log 3 log
M,
2 log to the base 3 log 2
3.
to the base 3.
log 2 base 3.
Yes,
Okay.
sir. Previously m is there. M. Yes.
So how it converted?
This was converted to 2 log to the base 3 to the power m.
Log base 3 to the power m.
Yeah.
This one.
Yeah. Yes. This formula is not explained also. It's new to us actually.
No, this is not correct. No, how it is correct? This is exactly equal to this. So
this is how it is solved, sir.
No, this is means here, this is m, sorry, 2 to the power m, no? This is come here.
No,
This
sorry, m to the power, m to the power.
M to the power. It is all about the m to the power, okay.
Yes, 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 yes.
So this
Sir,
is
in the, it is in the graded.
this is correct.
2 to the power.
yeah, 2 to the power. Yes, it will be exchanged. Yeah, this is actually the exchanged here. This is actually so see, this formula is not taught, but you can create this one. This is exactly see, this is Okay, if it is in this fashion and it is directly written there, this is actually converted by this way, right? This is, you can assume, this is why that's one thing that it is not mentioned in the lecture, but using that whatever in the lecture, no, using that formulas, actually this is generated. So if we assume this is y, so this is log. Okay, this is log. You have both sides. You need to take the log with base 3. So this is going to be here log, and if you take the base 3, this is m here, and this will become log 3 2, and this is log 3 base y. And now what this is, we want to change it in the fashion of 3 2, or this is m, this is 2. So this is written in this fashion. So now next is what we can do. If we take log here, this is log 3, and then both side we took the log. Now this is log just a minute.
Sir, I'll leave the derivation part, sir. We could understand that actually, but we need the formula. That's what I asked it. Sir, leave it and move on. Let us move on to week 8, sir.
Actually, this derivation is very easy, very easy. Actually, in very small way, it could be done. Okay, just a minute. It is very easily could be done. If you need to take log with base 2, this is log m. Sorry, this is log. Very quickly, it could be only 1 or 2 3 lines. It will give you the answer. That's why. Just a minute. This is 3 2 log with base 2 m is there, and this is log. If you take log with base 2, and then after, okay, yeah, oh, so this is, yes, now this is, if you assume now just change into exponential, how it would be, this is 2 to the power, what it come, to the power log 3 2 log 2 base m, which is y here. Okay, so I think we need to take the base with 3. So if you take with base 3, this is m here. This is log 3 2 log with base 3m, which is log 3y. And this is, again, if you take there, this is 3 to the power, no, we needed 2 base. So we need to take the log with base 2. So here we got this one, and this could be now this we needed, okay. This is needed 2 to the power 3. Okay. So actually now what is this here? This is 2 log 2 upon log 3. This is log m upon log 2. Now this could be cancelled out. This is y here. This is very straightforward. This is not a very complex. That's why the formula is not written this time. Now I actually reached to there. This is log m upon log 3, which is y. Now finally, this could be written as 2 to the power log. I will tell you what is I am writing here. Okay. Or all of you are getting what I am writing here? How I break this one, log.
Yes, sir.
Yes,
A,
sir.
B is there, so this could be written as log with base 10 A upon log with base 10 B, right? This is.
Yes.
This is using this only way. You see what I am doing here. This exactly I am doing. So this is written here. I just break with the log base 10, both multiplied thing. Okay. Now once I break, this is all happening on the log sorry, to the power. This is to the power it is happening. And in starting, I took both side log with base 2. Both side I took log with base 2. Why I reason? The reason is we needed a base as the power we have here. Here is this base is here. That's why I took the log with base 2. Once I took log with base 2, this will become what? This will go ahead. No, this is so. This is m, no? We forgot m. This is m. So once we take the log with base 2, this power will go to multiplication, and this will get. Now this is in the multiplication, and this we have. So again, now let's from the log we can back to the exponential. Just now I just back to the exponential. So this is y exactly equal to this one. Now this whole expression is nothing but this one. This expression is nothing but this one. That's why y equal to this we got, and y is the previous one, this one. So that's why both inequality, that equality is same. This is same. So only steps, 2-3 steps will take to get this. That's why I think that's why that not written in the that formula, that this is actually generated by this older we have whatever we have. Okay. And listed formula of the log is you can search on Google very quickly. You can get this here. This is the, see that this is the K, this is B, and also in exchanging form it is written.
But
Whatever
the
sorry.
conversion is very difficult. Means by practice only we will get, sir. So we need some more.
Yeah. Yeah, but this is the one of the extreme. You can say it is like, let me list out. This is the extreme case here. The log, if you have, this is whatever this formula is there. This is the extreme case. Let me write out here easily. This is log of A plus log of V. There are 10, I think, or 8 or 10 we have. Log of A by B, which is written as log A minus log B. Okay. The third one is log this is all on base 10 I am doing. It is very similar to the ln also, which is base E. Okay. And these two have, then log base 10 a to the power m is actually nothing but m time log A is 10a. Fourth one is log AB is actually 1 by log base AB. This is base change actually called. Okay. Fifth one is 1, 2, 3, 4, 5. Fifth one is, let me write that one also, log m to the power with base 10 I am saying here, or even ABC also, AB. This could be written as b to the power m, b to the power log with the same base, and m become. Okay. Any other formula I'm missing here? Let me list out here. Okay, a to the power m, a by, yeah, that's dividing form, no? If you have log base A, B is there. So all are positive cases. Assume A and B are positive. Okay, always assume A or B is positive. So this could be breaked. This is log 10B and this is log 10A. And any other formula I'm missing? This is done, addition, multiplication. This is done. This division is done. This is the same as the property of the log. And this is one. This is one, which is here. Seventh one is A to the power log, okay, which is B here, which is the same base here, A, and this is m, or small m. Power, and this base is same. In that case, this is m. This can be easily also proved, means it can be easily done. So this, if the base and here is the base are same, as you can see here, the base are same, then this will exactly equal to 1. Sorry, that power, that log values. And the eighth one also, you can assume log with any base of 1 is, this is a log property. So this is 0. That's all, I think so. Only one, this one is generally the people remember the addition, but this one is some kind of important, this one is, and this is also one important many times. It's look like very complex, but exactly value. So this one and also this one, it looks like complex, but very easily could be done. So these three are actually important. Yeah, and rest all other formulas. Yeah, this one also. This one is also very much useful to sometime. So sometimes the bases are not same, no. So in that case, let's change the all expression in the base 10 and then try to solve. Okay, this one is, these four are actually important. Okay. Now is it fine? No. Okay. So let's move on to derivative thing. So derivatives here. Derivative. So derivative is, somebody has raised hand. Yes, Manish.
Sir, if a function is bounded by one side, then what we can say, it is bounded or unbounded?
Function is bounded by
One side.
one side. Then in that case, it is bounded or not?
Yes, sir.
So in that case, you can say that it is bounded by, if it is bounded by below, so you will say it is bounded by below. If it is bounded by above, and then you will say it is bounded by above. But in whole scenario, if somebody is asking, then you will say it is not bounded.
Okay, sir.
Okay. Okay, so derivative. Is anyone got the writing permission? Please don't write here. Okay, let me write. Otherwise, it will be difficult for me to erase. Okay, so derivative is two ways you will see with the geometry and the algebra definition. So let's first think for the derivative, geometry thing. Suppose you have a graph, okay? So derivative is, in the simple word, derivative actually, in other word, it is a, that is actually give the slope of any function at that point. So slope actually give, let me write here. Suppose you have this function. I want to find the derivative of the function. Suppose you have this function fx, and I want to find the derivative of the function at a. So if you want to find your derivative of a, so what is the derivative means here? Here is actually we are trying to find the slope of the function at that point. So if you want to find the slope of the function at that point, how we'll find? So on the real line, if you are on the real line, and suppose 2 point is given, this is x1, this is x2, this is f of x1, means here y1, you can say y1, this is y2. So finally the point is x1, y1, this is x2, y2. So what is going to be in that case slope for the function and the real line?
y2 minus y1 by
y2 minus y1 upon x2 minus x1. This is the same. Whatever we have, this is exactly the same. So suppose this is a value, so this is f of a. Suppose this is the previous one, lesser than a. So assume the lesser than a is kind of a minus epsilon on anything. Let's say b. This is okay. This is b. So this is f of b. So we have this. This looks like a line. That's why you will say. But also we will do here also. This is a curve. In that curve type, we are trying to get the slope. So this is going to be what? Can you tell me what is f of?
f
A
of
minus
a
f
minus
of
f of b
upon a
by a
minus
minus
b. Yes. This is the slope you'll get here, but this is see, this one is a bigger case. Now we have a gap, longer gap. But can we do a very close to a? That close to a is, you can denote with the that close is, no. So see, as we discussing now as x goes to 0, what is the meaning? We are talking around very close to 0 number. That number we are trying to give the input which is very close to 0. So can we think very similarly here, which is very close to a and corresponding output that and change with that. So assume that very close to a is actually a minus epsilon. Epsilon is any very small number, very small number. So we are subtracting from a very small number. So then output will be f of a minus epsilon. That means let's again find the slope. This with the same formula, a minus epsilon minus f of a f of a minus f of a minus epsilon upon a minus, or epsilon in place of epsilon, let's write like this. H, that would be better. Epsilon is if you are getting the h, h is very small number, a minus h, very close to a, and output will be a minus h. So here is a minus h. That is now again a minus h, right? In place of b, we are subtracting a minus h. So this is finally f of a minus h upon h, right? This is h, or differently write like this, a minus h upon f of a upon minus h also. By this way also, these all are the same. Now see, this h is actually still very close to 0, but we want very close to 0. So then how we will represent it? What is the process then? Is there limit will play a role? If you want to tell something about very close to some number, so that is actually denoted by the x tends to that number. That is the process. If you want to say, that's why as x goes to 0, that means this telling a very close to 0 and getting around the output very close to 0, whatever the output. So can we do something very close to 0 here is also for very close to a also can we do here? So how we will write that?
Yes, sir, from right hand side.
So no, this is from left hand side, no? So we are approaching to with the getting that this derivative. So from left hand side, what is happening here? Very close to 0, we want to tell that when we can say that limit h goes to 0, right? That means you are h is very small. That means you are beside of a very close to a. That means that's why here you can denote with the limit. Limit is that's why the case is here. We are actually talking about very close to that number a. So that's why the limit will come here. So we can finally write f of a minus h minus f of a. This is upon h. Okay, minus h. So this is called the left derivative. Okay. Whatever we did here, see that from the left side we are doing. Okay. Similarly, we can do for the right side. A plus h, a number which is exactly greater than 0. So actually what is happening once we try to get this limit, no, this is actually this point. Let me make it red here. This point and this point is actually embedded. It is very close. Then you will get whatever the value, no, that is give the slope of the function at that point. Slope of the function means what? Slope of the tangent you will get. At that point, you will get a slope where what do you mean by the slope of the function? Slope of the function means you will get a slope of the line which touches the graph at that point. Correct? No, yes, no, please.
Yes, sir.
That's the meaning of the slope of the function. Slope of the function means you are getting the slope of that line which touches the graph at that point. That's the meaning of slope of the function. So derivative is nothing but that derivative is the more generalized form of this slope actually. This whatever the slope here we have. Here we are dealing with the real line. The lines, straight lines. But can we generalize it? When it will be the curve, then in that case, can we get the slope of the curves? So in that case, the slope of the curves is actually we are talking about the tangents. So that slope of that curve means we are talking about the slope of that line which touches at that point. Here is happening. This is actually when we made here, no, where h goes to 0 means now the point is very close to a, and that's why it is at exactly that. You once you try to find the limit, that it gives the slope of that line which touches at that point. This is the mean of geometry. Okay. Similarly, very similarly, from right side also we can approach. This is we did from left hand side. From right side also we can do. So that right side could be written as limit h goes to 0. Okay. This h is always positive. Okay. Because we are subtracting here, so h is always positive. This is the mean of here. H goes to 0. F of a plus h, a small incremented function value at that, minus exact value at that, upon divided by h. So this is called right derivative. And again, the same case as left limit and right limit. If left derivative and right derivative is same, then we will say function is differentiable at that point. Okay. And the derivative at that point is exactly limit h goes to 0. You can, with that same positive or negative, any one of you can denote. I am denoting with the positive case. The derivative is generally here is more generalized form. It says h is approaching to positive and negative anyway, but it is exactly mean to say left derivative and right derivative is same. Then you will say the function is differentiable at that point, and the value is actually called the derivate value at that point. Okay. But the needed is in the same case left and right limit. This is also we are generating a left limit, right? This is a kind of left limit. This is a kind of right limit, and we are doing the same. And derivative definition is exactly the limit definition. Limit as what is that? X goes to b f of, right, x plus b minus f of, what is that definition? I am missing something that no, we want to find yes. So x goes to, yeah, this is b upon x plus b minus b, which is b upon x. This is the derivative means, right? This is the derivative definition. Means here, if you assume that here is the left derivative and right derivative is embedded as, you can approach to b here from left and right. So that's why I took here from the starting initial time of the derivative, that left derivative and right derivative, and it is happening. This is the same. So here is actually, as we have this limit, so limit is evaluated as left limit and right limit. Then so that left limit is actually left derivative and right limit is, for this case, is right derivative, 0t. So let's do an example. What is that? Let's assume fx is equal to x to the power 5 plus 2x. Or no, let's do a simple one. X square plus 2x plus 1. We want to find the, we have function and we want to find the derivative of this function at a differential derivative value at this function at 5. So how we will find this? Can you try once?
Is it like a quadratic function 2x plus 2?
So that would be done. That is also, yeah, exactly. Remember that formula. Otherwise, we can, with the limit case also we can do, right? So let's find the limit with using the limit h goes to 0 or b goes to 0 anyway. So this is f of, so we want to find at 5, no? So here let's see that here is 5 means a. So 5 plus h minus value at that point upon h is there. So now 5 plus h is 5 plus h whole square plus 2 5 plus h plus 1 minus 5 square plus 2 into 5 plus 1 upon h is there. So this is equal to what this is now. Let's do something here. This has become 5 square, which is 25, and plus h square plus this is 10h, 2 into h into 5, 10h, and this is 10. This is 10 plus 2h, and this is 1 minus this is what it will get, 25, 10, 35, 1, 36 upon h. So this is now, let's solve. This h square is there, and this 10 is 10h, 2h. This is 36. This will become minus 35, and this is 25. So this will become minus 10. Finally, we have h square plus this is 12. 12 h, and this 25, this 35, and this whole will be cancel out, right? This will become 0. So 12h
Minus 10.
finally. So minus 10 will get. So finally, find included form this one, and this two will be all becoming a, after adding, subtracting, become a 0. So that's why I just cancel out. So finally, you will get the expression h square plus 12h upon h. So this is all happening, all limit h goes to 0.
Can we take the common h out, sir? H into h
Now, yes, h will be common out. So this is h plus 12h upon h. This will be cancelled out, and this is limit h. H goes to 0. Just now we need
H
to
plus
substitute
12,
here.
sir.
H plus 12, yes. Now just need to substitute here, so you'll get here 12. So this is the way to get that. So this will work for any kind of rational, irrational function, rational function, or any kind of sine, cos, tan, trigonometric, any function. So let me write the formulas also. So this derivative of this function, which is generally denoted by, this one is actually denoted by, let me write here, this is actually denoted by, once you are doing this, no, so dd, this is denoted by dd of x, okay, of fx. This is denoted at derivative of the function. This is actually the definition. So if you want to find this one, this is actually, we are trying to derivate this function with respect to x. So this is actually, this formula is there. So if you want to derivate this is the same, using the same derivative definition as we have h goes to 0, f of. So here is what is going to be the, at any function we are trying to generate is here. So let's assume at any, so let's assume a. So a plus h to the power n minus a to the power n upon h. So this could be limit. Once you try to generate, this will actually come as like this once you take the limit. So that's why this is also generated by the same definition. This formula is generated by the same definition. Similarly, this is the one formula, and derivative of the sine is actually sine x, is actually cos x. Derivative of the cos x is actually, what is? Minus sine x. Fourth one, derivative of e power x is what?
E power x.
E power x. Derivative of 8 power x is what? A is any greater than 0. Can you tell me? A power x, log is there, no? Log
A.
Log a, right? With base 10. And sixth one, derivative of log function. This one is what?
1 by x.
1 by x. So this is on base e, right? This is on base e. So ln will be good, better to write ln x. This is 1. So here is also, if base 10 is base e is there, so this will become ln a. Okay. So 6th one, 7th one, dt of x, log is done, exponential is done. Okay, cos, sine cos is enough. Tan, if you want to tan also, tan, what is the derivative of tan x?
Secant square x.
Sec square x. And that's all for trigonometric. No need to go with the sec and other all. That's all. And this is power done. This is sine cos.
Constant.
Yeah, derivative of the constants. dt of c. Let's assume this represent a constant function. So this is derivative of constant function is 0. This is the 7th, 8th one. So this is all about this. This is easily you can remember. If this is easily can be generated also, right? This is actually nothing but function value, function increment value minus function value upon h. Limit h goes to 0, and as the function is constant, so this is c minus c upon h, which is 0. So if you take the limit now, it is exactly 0. So very easily can be computed for the this constant function on the derivative definition. This is the same. Okay. And okay, that's all. Now, otherwise just remember with the lecture, and either you can just search on also here derivative formula. You will give the rest of to give a list of here, bigger list. Yeah, so something is remain. So derivative have the same as limit property. What is the property have? As limit can be distributed. So if you want to find the derivative of f plus g, that is the same as derivative. Also it is notated like this also. dt of x is actually, it is actually notating by this prime. Also this is also noting as generally a prime. So very quickly we can write also, this is f prime plus g prime. That means dd of x, ddx of fx, and ddx of gx. And this is f minus g over prime, means here again you want to try to derivate. This is f minus g prime, and okay, this is f by g is there. So this is one important thing. You want to derivate this f by g. Yeah, okay. Yes, Prayas will see it. Okay, just a minute, let me finish this derivative thing. So this is one formula. Just need to remember, this is important always. This is become f is, sorry, this is f prime g minus, what is that?
G prime f.
G prime f upon
G square.
G square. And if it is fg prime is there, then
f prime g minus g prime f.
not
F
minus, plus,
plus.
no?
Plus, yes.
G prime f. This is the formula. Okay. Yes, you can ask now. Okay. Okay. Yes, Prayas, you want to? Okay, Suprita.
Sir, I have doubt, sir, how to check 1 by EX unbounded or bounded.
1 by ex.
Yes, sir.
Okay, so 1 by ex is what? 1 by ex can be written as e power minus x, correct?
Yes.
Now can we tell me the graph of what is going to be the graph?
Sir, I do not know, sir, how to draw, sir, 1 by EX, sir. I
So
know
that's
the
why I'm
EX,
saying,
but
that's why I'm saying if it is in this fashion it's written, so I just converted in this way. 1 by ex is actually e power minus x, right?
okay, sir.
So, and you know, it is, you know, the e power x, graph of e power x is
Yes, sir.
one, right? This is,
Okay, sir. Now flip about the y-axis.
yes, now flip about the y axis. Now
Okay,
it should be exactly this one. Okay.
okay, sir.
Okay, this is one we done. Now derivative is, now just see the definition for derivative, sorry, the formulas for derivative. Almost we discussed this all. So actually, please remember this one, no? Okay. Try to remember this one at least a simple sine cos 1 by x e power x. At least whatever I just wrote here, at least remember this one. It may help you in the quiz. Okay. So please remember this one. Some problem may be on that. Just need to derivate. Okay. If it is suppose you have given function fx is equal to, this is sine x plus log or ln kind of ln x square plus, so composition is still remain, we will discuss here. So this is sine, or even let's say a to ax to the power n or 3 is there. So you want to derivate this function. What is going to be derivative here?
So cos x
Cos x plus
1 by x square into 2x.
1 by x square. Yes, the composition is actually the, if it is written as f of g and you want to find the derivative of it, so then what is the process? You will derivate first in the composition form and then into multiplication derivate this g. This is the process, right? So again, in the composition you have x square. It is a composition function of log and the quadratic. So just for derivate for the whole function as here in the composite form itself. So whole composite form, the derivative is 1 by x square. Now go to the inside function and derivate it. So as here, this is going to just derivate. So derivative of x square become 2x. Now again the same is here.
A q into 3x square.
So again ax. So again the same, x to the power n is actually written as n x to the power n minus 1 once you take the derivative of it. So this is 3ax. This is a composition, no? This is composition of a into x kind of thing. Please, Cyprian, mute yourself. This is a composition. So again, this could be written as in this fashion. So this is 3 into a power x. The whole composition derivate this whole in the composition function. As you know the formula, this is 2. And then do the derivative of inside, which is what? A is any real number. What you will get? A. Derivative of a into x is what? This will cancel out and a we will get. So this is, that means a is. So finally you have cos x plus, this will become what? 2 by x plus, this is 3a ax square. This is the prime of it. This is the derivative. Okay. Is it clear?
Yes, sir.
Yes, Prayas, you have some doubt?
Sir, 7.1, question number 11.
So what is that doubt? Can you tell me?
Sir, I unable to draw x upon 1 by x graph. Yes, sir.
X
Another
plus this
1 by
graph. X plus 1 by x.
yes, sir.
So is that problem asking for drawing the graph or something else?
Sir, question asked का injective function.
Is this injective or not? So last time I have discussed very, let me show you, it is already discussed. It is discussed on Friday, last Friday, I think so.
Sir,
Not
can
Friday,
I get this video on YouTube, sir?
Yeah, it is already on YouTube. It is already on YouTube and the channel of MA1001. It is already in the calendar. No, it is. Let me show you. It is actually very briefly we discussed
Okay,
that.
sir. First I checked, sir. If I found that, I told you, sir.
Yes, yes. So I can tell you it is happened on Tuesday. I took one. Yeah, Tuesday. So on Tuesday session, this one in the open session. Here is the link. You can go. If you go there, you can see I discussed a lot about this. Okay. So here, if you just see that in starting itself, I discussed.
Okay, sir. Thank you, sir.
Oh, what? Okay, forget this one. So, okay. So this is the derivative. And I think the last one is the derivative is done. And now the tangent, that is only exactly the formula. That is a very easier one. And otherwise, linear approximation. Oh, L'Hopital rule is there. Once you know the differentiability, so L'Hopital rule is what? Very quickly we can see. What is the L'Hopital rule? We can see and we can solve a problem also based on that. Okay. So what is exactly this L'Hopital? There. So this needed this L'Hopital rule says actually what? This needed an indeterminate form. What is the indeterminate form? Indeterminate form is once you're trying to get here limit, once you're trying to find the limit in this fashion, if it is, so if it is becoming a 0 by, once you try to find the limit, it is becoming a 0 by 0 form. Okay, infinite by infinite form, 0 by infinite form, or infinite by 0 form. Okay, infinite by 0 form. In this fashion, it is, if it is happening, this is called indefinite. Okay, indefinite form. And if your function is in this fashion, then the limit of as x goes to 0, f of x upon g of x, okay, this limit is exactly equal to the finding the limit as, or a is, let's assume a here, not 0, here is a. In that case, the limit as x goes to a, f prime x upon g prime x. Just derivate that function and again try to get the limit. So this is called L'Hopital rule. Okay. So if it is again asking, then again you can derivate it. More time, just derivate. How many times is it asking? You can derivate. But the problem is once you are trying to get the limit, this limit, if upper side is not negative, but below side, upper side is not becoming 0, but below side is becoming a 0, then you cannot apply. The reason is it is not becoming an indeterminate form. Okay. In that case, you cannot apply. Otherwise, if it is in this fashion, 0 by 0, infinite by infinite, 0 by infinite, or infinite by 0 cases is happening. So let me open it. It is not in these cases. It is, sir, is said if it is both going to infinite or both going to 0, then in that case, it's there. What is that in? Let me open it once. So indeterminate form is further suppose fx and goes to 0 or both goes to diverges infinity or both goes to minus infinity. So the indeterminate form is both goes to 0, both goes to positive infinity or both goes to negative infinity. Okay, in that call is indeterminate form. So this is not, you can include if both goes to infinity. This is positive infinity or both goes to negative infinity. Not even you can think this is positive and this is negative. This is not case. You can assume for the indeterminate form. Okay. So in that case, the same as This is called indeterminate form. We'll see an example there. This case says this limit is exactly if both just derivate and exist in the small interval except possibly at 0. It could be at 0, at A, it could not necessary to exist. Okay, but yeah, in the interval it is existed, and the derivative and that interval should not equal to 0. In that case, the limit as x goes to 0 is just exactly value the limit of derivate that, and limit or the function limit, whatever you are getting, is the same. For example, I am saying here, suppose you have a function. Okay, suppose you have a function sine, or this one, yes, sine x by x. Okay, what is going to be in this case limit? I want to find the limit as x goes to 0.
1.
This limit is 1, but how can we use here the indeterminate form or L'Hopital rule?
Yes, sir. 0 by 0.
Yeah, it is actually happening a 0 by 0 form. Sine 0 is 0 by 0 form. So we can apply L'Hopital rule. This is following the this indeterminate form. So then we can derivate. So derivative of sine x is cos x, and derivative of the this x is exactly 1. And now x goes to 0. Now as x goes to 0, just need to substitute. So that means cos 0. Cos 0 value is 1. Then that means this final limit of this one is actually 1. Okay, this is the L'Hopital rule. Or other function also, log 1 plus x upon x, this limit. What is going to be this limit? This is both
1.
This is 1. Why again? If you apply the L'Hopital rule, it is following, no? This is log goes to 0. This is becomes 0 by 0 form. So we can apply the L'Hopital rule. We can derivate. So this will become 1 by x. This is 1 by x, and this derivative is 1. Now we can just substitute the limit, so this will become 1, right? So this is the way to get the indeterminate or L'Hopital rule. And now the last one is we have tangent and linear approximation, which is nothing but a formula. So tangent, if you want to find the tangent of fx, let's assume fx is equal to, let's say, sine x plus 2x square. Suppose we have this function and we want to find the tangent of the function at x is equal to 2. So we have a formula for that. What is that formula? Formula is tangent. Tangent means we are trying to find the equation of the tangent line. So that equation of the tangent line is y is equal to, can you give that formula? Anyone?
F dash x.
F value, we want to find the tangent at 2, so function value at that point plus x minus 2 slope at that point, f derivative 2, right? Just remember that our formula, whatever we have, if suppose you have a slope of a line, okay, and a slope of a line and point is there, AB. So what is that formula to find the equation? Y minus b, right, is equal to m time x minus a. This is the formula, right? If you have a slope of a line and point is given, then what is the formula to find the equation of line? This one. And we just now discussing that this derivative, this f prime 2 is actually give the slope of the tangent. That means we have already given the slope, and point is what? Point 2 and function value of 2, right? The point is what? 2 and function value of 2. So can you compare these two formula are exactly the same?
Yes, sir.
This is exactly same, right? The x minus 2 is there, x minus a is there. Slope is multiplied, so slope is multiplied. This b is our f of 2, which is this side there, but we send this side. So easy to remember, no? This formula is also, it is exactly this formula, nothing else. And in this fashion, it is written as This derivative is actually nothing but the slope it's give of that tangent line. So this slope into the point x minus a, and this is b value and this is y. So this is the tangent equation of the tangent line. So in generalized form, if you have a function fx and you want to find the tangent at x is equal to a, in that case, y is equal to function value at that point plus derivative of that point, which is actually slope, derivative value, and x minus a. This is the formula for getting the tangent. Now, linear approximation. Linear approximation is what? Why we needed this linear approximation is there is a geometric interpretation. You can think it here. What we are trying to do here with the linear approximation. Suppose you have a graph, okay, this function. So linear approximation is actually, if we don't know about the function, we only know the linear approximation of that function. No, so we will try to approximate our graph with the linear lines. That is the use of linear approximation. We will try to approximate our graph of the function with the straight lines. That, oh, this is behaving like this, like this. These are our straight lines. You can think that. So you are approximating your graph of the function. This is the use of linear approximation. And linear approximation is actually a function. What is that function? Exactly this one, right side. That linear approximation of the function is actually a function. You want to find the linear approximation. You want to find a linear approximation of this function of this function fx at a, at x is equal to a. So the formula is actually linear approximation is a function in of a line. So this is x. This is exactly equal to function value plus derivative value or slope value or derivative value of prime a x minus a. Exactly right side of the tangent. This one. Only written as in the fashion of function. Okay. This is all about in week 2. We have. Now I am stopping my word. Please let me know your doubt, whatever we discussed now till. Please let me know whatever we did here. Maybe.
Sir, where will
discuss
this
something.
PDF be uploaded?
Okay, this PDF is with the with the same, in the summary section you will get that.
Okay, sir.
Yeah, with the name of it is the name what is written. Let me write here the date also if it is needed. The date we can give here is starting. So easily you can get with the date wise also. This date is 28.
Thank you, sir.
Okay, please let me know if anyone have doubt, you can tell me. Otherwise, now I'm going to close the session. Okay. So no one have. So thank you so much for joining. Now I'm going to end the session.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Excuse me, did the class happen? Hello? Hello? Did the class happen actually? Can anyone answer, please? Did the class happen today?